Chapter 3, Section 3, Grandmaster. Some critical thinking problems. Number 1, determine the length of the diagonal D. So here I have a box in 3 dimensions. We have the dimensions, length, width, and height. And we want to determine this diagonal here from corner to corner. How do we do that? Well, if this is 5.1, this being 3.2, this is also 3.2. So what I'm going to do is draw a right triangle just on the bottom. Now this of course is 90 degrees. Just doesn't look like that because perspective. There's my 90-degree angle. Okay. So I can use Pythagoras to figure out this length here. So this diagonal that would fit flat across the bottom. So let's do that. I'm going to label that, I'll call it Z. Why not? Call it anything you want. So we know that 3.2 squared plus 5.1 squared equals Z squared. So therefore Z squared is all this stuff, whatever it works out to be. Let's do that now. That's 36.25. And therefore Z is just the square root of that. So that is about 6.0208. Okay. Well, what do we do with that? Well, remember, we're trying to figure out this diagonal D. So I'm going to draw another right triangle, but this one's going to be standing up. Okay. The height is going to go up here, and this is going to be the hypotenuse. And this is 90 degrees. All right. Well, remember, this height here, because this is 3.8, this has to be 3.8 as well. Okay? And I've just figured this out from the one in blue. I know what that is. I know this is 3.8, so I'm just going to use Pythagoras twice, and then I can figure out D. So that means 3.8 squared plus this number squared equals D squared. All right. So I actually didn't round this in my calculator. I still have this number in my display. So if I hit square right now, I actually get exactly 36.25. And then I add 3.8 squared. So therefore, D squared is 50.69. So D, take the square root, I get approximately 7.1 nearest hundredth, 2. And that one's done. All right, just a little aside here. There actually is a formula that will give us this diagonal in one shot without having to use Pythagoras twice. Now I'm not going to get into the nitty-gritty details. I'll just give you the result. So let's say this was, I'll call that A, and I'll call this B, and I'll call this C. So A, B, and C are the dimensions of the box. If you want this diagonal D, the relationship is given as follows. A squared plus B squared plus C squared equals D squared. Okay? So it's like Pythagoras, but I have another term added. Okay? So I invite you now, take your calculator and plug in all the numbers and then take the square root and see if it works. So 5.1 squared plus 3.2 squared plus 3.8 squared equals, so now you should have 50.69 in your calculator, which is what I had here. Then you take the square root, and lo and behold, your D, you get about 7.12. So there's a nice formula for you. All right, let's go back in time a little bit. Question 2 says, what is the slope of the diagonal in question 2? Okay, so what's the slope of this line here? You may think, oh my goodness, it's been too long since I've dealt with slope. I don't know how to do this. Trust me, it's pretty simple. Remember, slope, 2 words. Rise divided by the run. Now on a graph, as we worked with before, we had to be careful about our direction because that would make the rise or the run negative. So you could have positive or negative slopes. Well, in this case, there's no graph here, and all these numbers are positive. So I'm not concerned about the sign at all. So we're just going to keep everything positive, which is nice. So the slope of this line here is just going to be the rise, which is up and down, and the run, which goes along here. Well, it turns out we know all of those numbers already. Okay, what's the rise? Well, the rise is 3.8. That was already given. What's the run? Well, that's this diagonal right here. Remember, that's what we figured out in blue. So this is 6.0208. Okay, so let's work that out. 3.8 divided by that number on the bottom, and I get approximately 0.63. So that's my slope. It wasn't too hard. Number 3, determine the value of theta. So that's this angle going up here, angle of elevation. All right, so we have a rectangle that's standing up, and then we have one that is attached, but it's lying flat. So if that's 4, so is this. So I think I'm going to find this diagonal out right across there, just like that. Right. So I know it doesn't look it, right, but this is 90 degrees. Okay, so I can just determine the hypotenuse here, and I'll call that Z. Why not? All right, let's go back to Pythagoras. So 8 squared plus 4 squared equals Z squared. That means Z squared would be 64 plus 16, which is 80. So this is going to be slightly less than 9, I can tell already. So you get approximately 8.944. All right. Well, how does that help us? Well, remember, we have a rectangle here standing up. So if that's 3.9, so is this. I think I know where to go. So this triangle right here in red, let's put that there. Okay, well, theta, the opposite, is 3.9, and the adjacent is Z, 8.944. I just figured that out. So that uses tangent, opposite, adjacent. So I'll do that one in red. So tan of theta is 3.9 divided by adjacent, which is 8.944. But it's theta that I'm looking for, so I have to work backwards. So I'm going to use the inverse tan. Okay. So let's do some number crunching here. Times. And I get about 23.7 6 degrees. And there we go.